This conference will now be recorded.
Okay, so we have seen how replication can be configured, how we can troubleshoot and all that, right? The next big, important technology for MongoDB is sharding. This is ultimate technology you need to aware of after replication. This is depend on replication only. Ultimately, the sharding is a combination of all replica sets will become the sharding basically. I don't start with this any slide. Before that, let us understand with the diagram the architecture, how the sharding work basically, how it actually distribute the data on what basis and what type of distribution models we have in sharding. Let's talk about that and then come back to this. Okay, just try to catch these points. If you understood, like if you understand this thing, the diagram, the slides are dead simple. The complete discussions on the understanding only. So basically, in sharding is also called as Mongo clusters. Basically, will also called as Mongo clusters or sharding. Sharding is a famous word. Clusters also people do call, but that's not official word. But anyway, so you have multiple replica sets joined to the sharding. I'll explain one by one. Just try to focus. You can ask as many questions as you have. It's not something I'll move on kind of. You can ask your questions. I'll start with the two replica set and then eventually we will talk third replica also. These are all replica sets and you'll have a config servers where all metadata where in which shard is actually data is loaded correctly, the address of the data. And there are router servers. This will route the traffic to the both this config server will go to the replica sets and application servers. We'll spend a lot of time on the diagram first. Slides are easy to understand if you understand this, right? So I'll call one by one. This is a replica set one. First set is replica set one. Okay, this is replica set two, and here replica set three. Okay, these are all config servers. Config servers. These called mongoose or routers. Router servers are mongoose. Actually, the word we say mongoose, but people say router servers. Router means they actually route the traffic. Nothing else they do it. And these are all applications where the connections are coming from. Okay. So now all applications will hit the router servers basically to get the data from the background. It can be this or this, all or anything it can hit basically. Now the config servers will hold the complete, like distributed data basically, only distributed data. So we can run a database without you can keep the service in sharding. One database you don't want to shard. Why? Because it's very small. It only keep the data in local to one replica set if you don't shard it. So that kind of data config server does not keep much basically. But anyway, it's kind of this is going to maintain your all replica set servers which are involved in the sharding basically. We'll see anyway. We'll talk about. So this will talk to one primary replica. The primary replica will take the connections to the respective data node where you have the data. This is a data node, this is a data, this is also a data node, but these are all standby for it. If this is gone, this will become automatically primary and start responding it. As the end user does not see any kind of downtime. You don't have this kind of architecture in RDBMS. You don't have it. You will have always on, that can protect the data at server level. If one server goes down, other server will be up. Even Oracle also, if you take it, there are multiple servers you can write, but at the end you can write it to one storage itself. Okay, let's move on. So this can hit the config servers. Config server will take to the sharded server to get the data out of it. So it depends what you're trying to configure. This is something a collection level technology. It's a collection level technology, not the database level, not server level, collection level technology, I would say. See, when we do the sharding, when the collection becomes very big, uncontrollable, basically, if you have, a database, one database, you enable the sharding. First, you have to enable the sharding at database level, then collection level. Which collection you do the sharding, which are, becoming too big, like TBs of data is getting accumulated in a single collection. Maybe 100 GB is also qualified. 100 GB single collection, you can shard it if you already have a shard. Other data, other collections are too big, and one of the collection is trying to become big because the data is keep loaded into it. You wanted to distribute that collection data, you can make a collection sharded. It is simple command. First enable the sharding at database level, then whatever the collections are becoming bigger, and shard them. When you shard, what happens? The collection data will start distribute into all the nodes equally in terms of chunk. See, there are many background thing I'll talk about. This will take quite a long. Okay, so we have two types of sharding models we have in Mongo: range-based sharding model, range-based sharding model, and hash-based sharding model. Hash-based sharding. I'll tell you when do we use each. There is a significant change is there, based on your requirement. You have to choose the range based or hash based. And also there is something called chunk, data divided into chunks. Basically each chunk is equivalent to 16 MB, basically 16 MB data. So if you're like if you're sharding a collection, it must be at least we will consider as 100 GB collection or 50 GB collection. And it is not like 1 GB 2 GB collection. We don't do the sharding. We never do the sharding for small collections, only for the large. Whichever is growing bigger and bigger and bigger, that you are keeping in a single machine, the single machine will throttle up, like it won't give you the good performance IO wise and computing wise. Why? Because you are keeping 1 TB collection, 1 TB collection, you're reading a lot of data out of it, and one machine is hammering all the time. So you take the advantage of sharding so that that particular data will be divided into multiple replica sets automatically. You don't need to do anything. Just add the servers into the shard. Shard will take care of the migration of the data automatically. How it will move the data, we are going to see everything in practical. I'm going to show that clearly. So data divided into chunks, basically. Chunks. Each chunk is equivalent to 16 MB. If you wanted to form if you are loading 116 MB data, you sharded the collection. One more 16 MB, like 16 MB is exceeded, more than data is coming, one more chunk will form and data will start loading into it, like that. So there is an algorithm in the background to distribute the data. What algorithm it runs? Basically algorithm for the range based, hash based, anyway, by default it will distribute data equally across the replica sets. This is for the range based sharding I'm talking about. Hash based you don't need to do, but anyway, let's talk about this. If your chunk count is 1 to, okay, I guess 1 to 8, 1 to 20, actually 1 to 20. I'll tell you, we have theory there, I'll talk about again. If your chunk count is 1 to 20, less than 1 to 20, 1 to less than 20, then it will try to keep the difference only 2 chunks difference in each node. If your chunk count is greater than 22, greater than 22, 7, less than 80, let's say this, less than 80, between greater than 20, less than 80, the difference of the chunks are 4. Greater than 80, okay, greater than all above 80, the difference would be 8, basically. So now I'll tell you, just try to follow very closely on this discussion, because this is something you don't catch it on the one go. You have one collection, assume a case, empty collection, you sharded it. Let's assume that way. And it is filled one, it will start with one chunk. One chunk is equivalent to 16 MB. 16 MB means a lot of data, not small data anyway. This is filled, then what does it will do? Once one chunk it is created 16 MB. When 16 MB is completely filled, okay, the 16, it's not a 16, it's a 64 MB, I feel. Just a minute, let me see. 64. It is 64. Absolutely 64. Right, 64 MB. Default chunk size is 64 MB, right? Not 16. Just a minute, guys. If you don't, if you read on the website, you don't understand this technology. Seriously, you need to understand here so that it will give you, like a great boost up to understand this technology. 64 MB each chunk. Okay. If 64 MB is reached, 64 MB 200 KB maximum threshold. 64 MB 200 KB. If it forms that one, if it fills that level of range, chunk will, it will split into two chunks basically. One chunk will become a two chunks here like this. It will split half of the 32 MB here, 32 MB here. Okay. Again, this will grow up to 64 MB. Again, this will also grow up to 64 MB. Once these two are also become 64 MB, this will also split into two parts. This will also split into two parts. So here again, this 64 MB, 64 MB. First, it started with 64 MB only. Okay. This, whenever it is become 64 MB, the existing chunk will split into two equal parts. It will distribute the data. So 32 MB, 32 MB is split out. Then there is a scope like two chunks. Two chunks can become again 64 MB, 64 MB. Whenever this becomes 64 MB, 64 MB again, this will split into 32 MB, 32 MB. It is chain kind of thing. 32 MB, 32 MB here. Okay, like this. It will grow on. So again, you get the choice to four chunks are formed now. Four chunks again, each one becoming 64, 64. Then this will become split into like 2, 2, 2, 2, 2, 2 kind of. It is like that. So this is got destroyed. This got destroyed. The final count is this one. What the number of chunks is. Why? Because the existing chunk is splitting into two new chunks, and the existing is gone. It won't be there anymore, which means that the last one you have to take into consideration. Here, four chunks are there. Four become eight. Eight becomes 16. 16 become 32. Like that, data is keep growing. The number of chunks will split out, and data will take up to 64 MB. Again, it will split out. The splitting and load balancing will happen automatically. How the load balancing will happen? Based on this count, basically. This is the main important thing you need to catch here. See, guys, every collection will start with one chunk because you're started the collection. I mean, just I'm taking an example. If you have 100 GB, it will form lot of chunks. All the chunks automatically distribute the data. 100 GB data, assume a case you have 100 GB. When you shard a collection, it will make 33 GB here, 33 GB here, 34 GB maybe on the first one, because of the 8 chunks difference. So 34 GB, 33 GB, 33 GB automatically distribute data. You no need to do anything, just single command. One single command will make the collection to distribute across all the replica sets. One single command. How it is going to do, we will see that in the practical section, not now. But try to understand how data is getting distributed, on what basis it is getting distributed. That we need to understand. If it is a range based sharding, we are talking about the range based sharding for now, not the hash based. Hash based I'll pick up a little later. If it is a range based, what happens? If you create a database, even though it is a sharded database, sharding collection, if you create a database will get created on one of the node first, only one node, one of the node. Even it is sharding also, you are creating a database, new database. It will create randomly in one of the node, one of the replica set node. Okay, if it is created here, example, I'll see here, this is something is a collection level technology. We will talk about one collection first. Whatever you discuss for it one collection, it applies to all other collections same way. There's no separately. I have to talk it kind of. You create a database first, database will go and create in one of the replica set. It is a default nature. Anywhere it will try to create anywhere any of the replica set. If it is created here, you create a collection here. Okay, this collection you enable the sharding, not database level technology. It is a collection level technology. You enable the collection sharding when it becomes beyond the control. First thing, let's come from the ground so that you understand. You have only one chunk of data in the collection. One chunk means below 64 MB data you have in a single collection. You sharded it. When sharding becomes 64 MB, it will split into two chunks. Two chunks, right? Two chunks means what happens here? Difference is 2 minus 0, 2 only. So if it is split one more chunk, two more chunks, assume a case, 4, it will become 4. So now this 4 is definitely difference is greater than 2. See, when it is 2, when it was 1 and it is occupied 64 MB, it's split into two chunks. Two chunks again split into four chunks because they occupying the more and more space. 64 MB is reaching, it is splitting out. When 4 become here, distribution will start. Why? Because 1 to 20 chunks, in between 1 to 20 chunks, the difference should be between the replica set of a collection is only 2. But here we formed 4. So what happens? It will give one chunk here, one chunk here, and automatically it will take out. It is moving the data, physically moving the data from one replica set to other replica set. All the writes will go on here only. Why? Because in a range based sharding, you write into one shard, we'll call this is one shard. Each replica set is called one shard member. This is one shard, this is another shard, this is another shard member. Members will call it as, okay. All the data is getting written into the this replica set only. Based on the difference of the number of chunks, will start distributing the data to other sharded nodes automatically. It look for this difference up to 80, less than 80. It looks for the difference of 4 only. 4, see, greater than 20 and less than 80. If example I have 20 chunks here, and here example 16 chunks or 17 chunks, 3 chunks difference is there, it will start distributing the data automatically to make it equal. Yeah, Brent, go ahead.
Okay, when you said that initially on the first replication set, if
Hmm.
both the chunks reaches at 64, right, then it's going to split it into 4.
4, that's correct.
So replica set 2 and replica set 3 should be having 2 each, right?
See, everything will loaded into one replica only. It is
Mhm.
writing all the data into one replica. Whenever it is picking 64 MB each chunk, it is splitting automatically two parts. When it is splitting, the count becomes more. When the count becomes more, the difference comes. This difference comes. If
Mhm.
this difference comes, it will start distributing the data to other chunks other shards automatically. See, 1 to 20, the difference between these three, this and this three is actually 2 only. But here it made 4 chunks. 4 chunks means what is the difference we have here? 4 minus 0, 4 on. See, 4
Mhm.
minus 0 means difference is 4. 4 is qualifying the condition. It will start giving one chunk to this one. It will keep 2 chunks. Now, if you 2 minus 1, 1 only difference. If again it will split, what happens? What again it will split? 4 it will happening. 4 minus 1, 3. So it will give, it will again distribute the data. These two chunks will be given to two chunk. One chunk is given to here automatically. Here one chunk. Here one chunk. Again, here it will split because you're writing only one shard only, not in other shards. You're writing here, and based on the difference of the number of chunks, it will start distributing the data to other shards.
So replica set 1 will be having only 2 chunks all the time.
Not all the time again. Now it is split into four parts. Assume a case. Okay.
Mhm.
Now what happens? Again the difference is 2. Again what it does? Difference is 2. It will not give the. It is only 2 greater than 2, right? It has to form one more chunk. One more chunk means 6 chunks are formed in this case. Okay.
Mhm.
Now it will start distribute the data. Here 3, here 3, here 4. Difference. It looks for the difference. not two only. First case, as it now become four. Here four, here three, three.
Mm-hmm.
Now four chunks split into eight, assume a case. Then difference will automatically, a very big difference is coming. Then it will try to distribute, like this is three, right? Distribute to two, two. It will become five, five. Here it will become four, kind of almost equal. Almost try to keep the chunks equally, but two differences, two chunks difference maximum.
Mm-hmm.
It is growing the data here. It is growing all the data here only. But when the chunks are, splitting out and more chunks are forming, it will try to keep the difference of two only between the this one and this one and this one. Only two difference, as long as the chunk count is 20. If it is greater than 20, it will keep the four chunks difference. If it is greater than 80 chunks, it is forming. 80 chunks means here you have 88 here, here 81, 81, it won't form, it won't migrate. 88 become 92, assume a case. Here 81, the difference become more, then it will start distributing the chunks automatically. It looks
Mm-hmm.
for this differences when it is moving the data.
Got it.
Got it, right? So in range-based sharding, what happens basically? You form the sharding on one collection from one replica set. Always it will write to that replica set only. One replica set you write on the collection, and then it is distributing to all other shards based on the difference of number of chunks it is forming on that collection. Each chunk is 64 MB. So a chunk no need to be 64 MB to qualify to migration basically. That we'll say anyway. Whenever two chunks formed into four chunks, 32 MB, 32 MB, it is qualified to migrate automatically. It is loading the data. It is loading the data into the chunk. And if the difference comes automatically, it will move the chunk to the other replica based on the count basically. So you are writing all of the data into one shard and distributing to other shard basically based on the difference that you are keeping in between the shard nodes. This means what? You are writing all of your data into one replica set only. So you are hammering one server for all writes, but distribution anyway it will taking care of in the background automatically. Auto balancer, auto split. Auto split happen when the chunk becomes 64 MB, 64 MB 200 KB basically. It will split automatically. That is, auto split is a background of process which will look at the chunk size, and it is looking at and splitting up the each chunk when it becomes 64 MB 200 KB automatically. The load balancer always look for this change for each collection level, and it will migrate the data automatically when the differences comes into this conditional statement. It is fully automated. We just need to understand, and I'm going to show how things are moving in the background physically. I'm going to show that number of chunks we have in the first shard. When we enable the shard, when becomes differences becomes more, uh, this formula it will run and automatically migrate it. We can see that how it is migrating also. We can see how many chunks are migrated also because of the data splits. Trying to follow?
Yes.
Everyone say something, don't keep quiet. This is very, very important. You don't get the like this theory. If you see very book is written on the sharding understanding architecture only, a lot of people written a lot of books. You don't understand if you read on the website. So that is why ask me as many questions as you have. The config server, what it is doing, where each shard is sitting, how much of data range is there in each shard, this will keep that data. It's a metadata. With if config server is down, you cannot read the data because you don't know where the data is. The config server is holding all of your sharded data, even replica set data, everything, whatever is there, it is keeping the metadata. It is information, not the absolute data. It is information only. Okay, this database is sitting this shard, and these many collections are sharded, and this collection chunks are here and here, and each chunk is holding. This is the range of each chunk data. It is holding all the information, complete metadata of all the sharded nodes. Without config server, you cannot pull the data out of the shard. We cannot do it. Why? Because it is such an important servers. all Mongo routers will contact the config only. They don't contact the data nodes or sharded replica sets. They'll contact the config server. Config server knows where data you are trying to read some data. The data where it is sitting, in which node is sitting, in which chunk is sitting, chunk is moved to which shard actually it is moved. Everything is there here. It is kind of index for you. It will take you to the respective node and pull the data automatically. There's the data information. You have the data information because you are reading some data. The data is sitting somewhere in one of the sharded replica. Just a minute, guys. It is simple if you understand. If you don't shard the collection, it will sit in one shard replica only. All the data will sit in one replica set only. When you shard, it will start the distribution. Based on what? Based on this difference. And each chunk it will form. When you shard only, it will divide the data into chunks. If you don't shard, it is like a continuous storage in one replica set. It won't form the chunks. It is a continuous data storage. When you form the sharding and the collection, the amount of storage will divide it into sharded chunks, basically chunks. The chunks automatically will convert and migrate to other shards based on the difference that you see when you convert the complete storage into chunks. If you have 100 chunks, assume a case, and each GB, how many chunks it is forming? Let's calculate this. I'll tell you this, how it actually happens. You have 100 GB. Each GB, see, each GB is equivalent to 1024 MB divided by 64 MB. Each GB is going to create 16 chunks. Then 100 GB into 100. Total for 100 GB, 1600 chunks it will form. 1600 chunks. So you have three replicas here, three replicas. So divided by almost three if you look at. So roughly 533 chunks in each machine. Maybe the first one might be holding of like a 560, and these are holding 553, 552, something like that. 552, 552. This might be holding more than that because the difference here it look for 8. First one it will keep 8 chunks extra because whenever it becomes more than 8, then only it will try to migrate to other sharded replica. So that way 100 GB table is forming 1600 chunks. 1600 chunks, 550 chunks are moving here and here, and roughly 560 or 558 chunks are operating from the this one. So it is almost equally it is divided the data. Only few MBs of data. Few means 8 into 64. How much data it is? That is the difference you see it. 8 into 64. So roughly half GB. Like you have here 100 GB means 33.5 GB or 34 GB you see it here, and 33 GB is loaded here automatically. 1 GB or half GB difference you see when you do the sharding and the range based sharding. Range based sharding is something you write into one replica, it will distribute automatically in the background. Hash based is something it does not need that. Yeah, Brian, you go ahead.
Okay, so the replica sets second and third, they are not going to split it further. It just
No,
keeps on adding. It just keeps on adding one chunks.
that's it. You are absolutely correct. It does
Mm-hmm.
not, you don't split the data here. Only splitting happen on the where it is created
Replica
first,
set one. Okay, got it.
right? Splitting, loading only forms here only. It is only just taking the data from this one to
Mm-hmm.
have the physical data distributed. When you read, you will read from all of this because data is, it's not in one shard. It is there in three shards. It knows it will distribute the read connection to all the shards, and it will get the data out of it and then send it to the router. Router will get the application. That's a good question. Very good question. You are writing all splitting and data writes are happening on one shard. It is distributing the data in the background to other nodes automatically based on the difference of chunks here. These many differences. That is the range based sharding. If you take it up to hash based sharding is different, quite different. Let's talk about that. Hash based, what it does not look for the difference at all. If you are loading one collection, first it will create 64 MB, 64 MB, 63 three chunks it will create by default, empty collection also. Then it will writing the data one. If you are example, if you are loading 100 records, assume a case, 1 2 3 4 5 6 7 8 9. So when you are loading itself, it is writing the data into each shard equally. It's not writing into one shard. If it is a range based, it is writing into one shard and balancing is taking care in the background. But hash based is not like that. When it is writing itself, it will balance it. It will not migrate the data. It will not migrate the data. For if you have already data, you form the collection sharding, it will distribute equally on all sharded nodes, equally, almost equally. It does not keep the differences. It will distribute the data on all shards automatically, equally. Whatever the data further is coming on that collection, it's a collection level. On that collection, further data, if you have 100, if you are loading 100 records, assume a case, 1 2 3 4 5 6 7 8 9. It's like a load balancer, like a round robin fashion, 1 2 3 1 2 3 1 2 3, like that. It will keep distributing the data. When it is loading itself, you don't need to rebalance again. Following? Range based, hash based are two different mechanisms. Range based will write the data in one replica set only. The splits will happen based on the size of the chunk is growing beyond 64 MB, and this data will get distributed to other shards based on the difference of this. This is what you have to exactly catch in the range base. Hash base is not like that. When it is writing itself, it is just writing the data equally in all shards, like round robin fashion. It is writing equally. Okay, writes will be faster. Why? Because it is writing in three different machines. It is writing quite fastly. Why? Because three machines are writing the data. Okay, here writes are too fast, but reads are slower. Why? Data got shuffled. It's not in the if I'm reading a chunk of data, all the data chunk data in the sequential order, it can read quickly. If data is actually distributed and jumbled out, then it takes time to read out the data. That's the problem with the hash based sharding. Re Which one is mostly used in ideal, right? Depends. You cannot say that which one is most, which one is less. It depends on the business, what they are doing. So I was talking about that, if you guys remember, op counters. If I even is doing how many inserts done, how many updates done, how many reads done. Do you guys remember that? I discussed that part. So in range based sharding, you see the write slower and reads faster. Why? Can anyone tell? Reads faster. In hash based sharding, writes faster but reads slower. So which you wanted then? So let me tell you this, there is nothing ideal, guys. You need to understand the environment before you form the sharding. You don't do the sharding, you never do it. You configure it and give it to them. It is a developer responsibility to form the sharding, range based sharding or a hash based sharding. We never do the sharding as a DBA and a collection. We will configure the technology, we will troubleshoot. For troubleshooting, you need to understand how things are working, how sharding works basically. That is the reason I'm picking this one. Anyway, you can suggest if you have a good knowledge what sharding it is suitable for the business. Example, people are writing too much data but reading less data, go with the hash based. See, they are loading too much data means they are generating a lot of data, but reads are lesser. Only you are reading for one management and you are not giving the data to too many people, only for your company keeping as an archival data whatever is coming, and you are reading occasionally, not too many time. Then go for the this hash based sharding where your reading is very rare but writes are very frequently happening. Range based sharding, writes slower but reads faster. You are selling the data all the time to the third party. There are many companies are there, they collect the data and sell the data to third party companies. Basically it happens, there are many companies in the market. Data means like browsing data and people interest data and something kind of clicks, web clicks data. they'll they'll collect the data from people and give it to some respective bodies who want that kind of data, so that they can sell the product to the interested people. There is something, artificial intelligence, you don't involve into that level, but artificial intelligence, what it does, every click on the website, you go and connect to website, you click, every click is actually recorded, and based on the clicks you do, they'll calculate what kind of interest you have, what kind of person you are socially, and what kind of personality you are. They'll calculate it. That's how, this election, before the election, they take the people's interest, and they'll push the respective interested videos to the people. I mean, that is a too big topic, I don't want to get into that level. But anyway, the artificial intelligence which will capture all sort of data. It can be anything, like you're using your mobile, using your app, and that app, they are actually, what you're trying to do in the app, they're collecting your data, and based on the clicks you do, based on the visits you make, based on the data you load, they will analyze this person is kind of this kind of person. Based on the activity you create on the system, they can analyze you each person mentality and personality both. That's how artificial intelligence work basically. So now, why I'm discussing all of this? Based on what? Come on. So in hash based chunks, just keep on sharding chunks, adding by number one each replica. See, yeah. See here, you already distributed data equally. In hash based sharding, data is getting loaded into each replica set in the equal order. So it will split the chunk locally. It won't migrate. It will migrate if there is a huge difference, because one went down and these two are only writing the data. When it comes online, whatever the difference is there, it will sync automatically. But if all are online, no migrations, no too much of migrations will happen. So hash based is efficient than range based generally, but what you're doing with your business is also matters. You're only, like writing less, reading more, go with the range based. Why range based is faster when this is slower? Because in this case, multiple machines are reading the data also. Here also multiple people are reading, but the thing is, data is continuous. It is keeping 64 MB data in 64 MB data or 32 MB data. That 32 MB data is in sequential order, because it is taking the data in the order and slicing it and sending it to other one. So whatever is there, data is there 32 MB, it is absolutely in sequential. When you're reading such a range of data, it is quicker to read the data. It does not go to 3 nodes to find 32 MB data. But here in the hash based sharding, every, see, as I said, 100 records, if you're trying to load, 100 records are loaded in 3 nodes and jumbled fashion, 1 2 3 4 5 6 7 and 8 9 10, like that jumbled fashion. It has to work on that, forming the data, what condition you run, and or based on that condition where the data is actually sitting, it has to evaluate more. When it is evaluation more, the more time it takes, the more time it takes to respond as well. So here reads are faster because data is continuous. Reads are so slower because data is not continuous in each chunk. Each chunk has a jumbled data. That is the problem. Writes are faster because it's writing to 3 different nodes at the same time. So what your business is doing, based on that, you have to select the sharding. There is nothing like this is only you have to do, kind of. You guys following?
Ravi, one
Yeah,
question,
go ahead.
Ravi. So replica 2, replica 3, in the range-based shading, the insert won't have that, right?
Right,
Insert or update.
right, right.
So
But
then, yeah, once
hmm,
the split, once it's reached the 64 MB, the splitting will happen, right? So,
that's correct. Hmm.
yeah, if that 32 MB ka file, it will goes to replica 2, right? Like after it's reached 20.
Right. It never get written anymore. It will stay that 32 MB only.
Okay, that file grows 32 MB and moves to replica 2. So in the replica 2, the 32 MB file only remains, right? It won't grow,
No,
or how it is?
it won't grow. It won't grow. It will grow only here and then distribute here. When the split happens,
Okay.
split only keep 32 MB. It will migrate here. Whatever the left leftover chunks here, they will grow again, they'll split again, growing and splitting, growing and splitting, and migration.
Got it. So in the replica 2 and replica 3, I can see all the files are in the 32 MB,
Yes, yes,
right?
yes, yes, yes,
Got it.
that
Yeah.
way it is.
Yeah.
That's correct. And here we talking about only one collection. So one collection is writing here, okay, but other collection is sharded here, but other collection is writing here, and it is getting distributed to other shards. So all the nodes are working based on the where the collection is sitting. We are talking only one collection, right? You have other database also, other collections also. Other database, other collections are not sitting in first shard only. They can sit on here, they can sit on here, they started distributing from here. So it is a collection level where the collection is sitting there. You are actually writing it. Writing is also not all the collections data is not going to one shard. It's not the case. When you create database, you create database from the router. You don't talk to any data node in the background. You only connect to the shard using the mongoose only. When you create a database, this config server knows that one database is created here, one database it will create randomly. You don't have control on that one. Wherever, see, database 1 here, database 2 here, database 3 here, it is created randomly. And you starting the collection, one collection, this sharding, it will distribute to these things. Here you collection this one, this is distributing to these two. This is this one, it is distributing to these two. So, but ultimately, each collection is writing into different shards or multiple shards. Maybe two shards are distributed, but other shard is not created at all. It happens. But wherever is the ownership of the collection is there, there it writes data. But all the databases will not go into one shard in the background. You don't understand this one. You keep it to one collection right now. When we start the practical, you definitely understand what I'm trying to say. Why? Because I'll create the database from this only. Whatever you do, you have to do it from the mongoose. You never connect to the backend servers. This config server will take it, will read all the sharded servers and give you the all database list. One database, if I create example, if I create one database from here, it is created here. One database I created, one database is created here because for the load balancing, it is created. When you see from the mongoose, you see all database list. If you come to the background, you see one database here, other database you don't see it here. Other database you can see it here. Okay, why? Because this is already divided the databases. Backend we don't connect. In the backend, this backend servers will call the each chart is a backend servers. Only all connection administration will be done from this servers mongoose only. Complete administration. We do the sharding from here only. You cannot do from the backend. You have to do from the mongoose sharding and all. Everything controlled, managed from the mongoose. And this will take care in the background where how many servers are there in the sharded replica, where database is created, how much data is there in each shard. This will get us the information. We don't connect physically. If I distribute the data, example in the range based, here you have 100, here you have 200, here 300. If I connect to the backend server, 1 to 100 only you'll see it. 2 to 100, 3 here you'll see it. 3 to 400 you'll see it here. So if you wanted to read all of its content of collection, you have to read from the mongoose only. Then only get the all the data from each shard and give you the complete collection data from here. In the backend, you don't get it because data is already distributed. You have the chunk of data in each shard, not all the data, but only mongoose collect the data and give you consolidated data based on the query you do it.
So basically, replica set 2 and 3 are just the copies of the sharded ones. It doesn't, those servers are used only for to keep the copies.
Exactly. What you said is absolutely 100% right. This is keeping the data. We never touch this one when the sharding is given. Only complete 100% administration we do on the router. This is what we connect. We enable the sharding, we create the sharding, everything is management and everything done from the mongoose. You never connect to the backend servers. You
What
don't deal
about
with
the
the backend.
replica set 1?
Everything,
You
all the
don't touch
sharded
that.
replica set one means this is also will be shown here. One database, see what happens. Let me quickly finish this topic, then we need to enter into slides also. See, just try to understand now. I'll try to close this topic with the one database, one collection. The same thing applies to all everywhere. So right, see, you created a one database got created here, and
Mhm.
you created a collection got created here, one collection. Okay, it is every database, every collection will not come here when you create basically. New database, maybe you created one more database is loaded here, not there. One more database loaded here. It can happen. It will load balance automatically. You don't need to worry about that. Anyway, this collection is growing very big and getting a lot of data. Then this will be considered for sharding. When you shard in the range based, what it does, if it formed example 20 chunks, assume a case 20 chunks means what happens in this case, 20 chunks, three shots divided by 3, here you'll find 8 chunks here, 6 chunks here, 6 chunks here, difference exactly it looks like this, 8 here, 6 here. And database also, the database was not here, it will create database when it is migrated. Database and collection both, physically it will appear here and here when the migration happened. Why? Because it has to make the database entry and take the data. See,
Okay.
when you have physically one database only was here, when the migration done, it will create the database, it will create the collection, and these it is moving all the chunks there. So you see the database entries in all the nodes that time.
Right, right. Okay,
That way it is.
basically it's all the replica 1, 2, 3. They're all kept for the copies, and but the sharding may only happens on replica set, and it once the it reaches its size and it starts splitting into replica 2 and 3.
Not the size, difference. Size actually
Yeah,
split in the
the
local
range
locally
of
only.
what I mean.
Yeah, the range difference comes, these
Yeah.
numbers, then it will start distributing the data to other charts.
Okay, okay.
That way it is. And
So
has
for the sharding purposes, that means it requires 3 copies of servers in order to shard the data and keep them.
right, right. This replica set is mandatory. Why? Because if you keep standalone also, you can farm the sharding. Standalones also, you never do it. Why? Because this is down. This complete range of data is down. Still, they operate with other two. They see that is a big advantage with the Mongo. If it is RDBMS, one data file went down, complete database will go down. In
Right.
sharding, it's not like that. If one replica set is completely down, it is still operate with available sharded replica sets, and it'll give the data whatever is there in the two charts. You don't go with out of data.
And minimum it has to be 3 replica sets, or it can
It
be lesser.
it depends. We have 5 sharded replica in our environment production.
Okay. It can be less than 3 also.
Less than 3 also. 2 also fine if you have less data. If data is growing more and more, and everywhere data is becoming more, add one more shard, automatically distribute the adding one shard is enough. It distribute the data automatically.
Oh, okay, okay.
You have an example, you have 40 GB, 40 GB, 40 GB. How much? 120. You added one more shard automatically, it will divide it by 4. 120 divided by 4, 30 GB automatically will form. It is, here 10 GB it will give, here this will give 10 GB, this will give 10 GB, this will become 30, all rest will become 30. Just add it, it will take care of the distribution.
But it's not like, for example, like the database copies are divided here, not like they're not each copy of it. It is the sharded in the sense it's divided. The chunks have been divided into 3 servers, and in
Yes,
order to get this data back again for any purposes, reporting purposes, something like that, so you need to get it from the Mongo router, and you will
exactly.
be able to access those data from the 3 servers through config to routers, because config knows how the data has been divided into 3 replica sets.
Wow, you concluded better than me actually.
No, I just saw the diagram and then try to understand the things.
Yeah, you really concluded better than me, I would say. Why? Because data is distributed. If you read from the backend, you see the chunk of data because it is distributed. Each copy is replica is having a subset of data, not all the data. If you want
Right,
all the data from all replicas, you only can get it from the mongoose.
right. Because when you keep the copies, you're using that somewhere. So that's my idea. So because it's going through config, and the config should have that information, and then it should give it back to either replica or to the router.
Exactly. What you said is 100% correct, and it is good conclusion what you said.
Okay.
So
Thank
A
you.
anyone
question,
have?
Ravi?
Yeah, go ahead.
Yes. So you're saying when first replica set is down, that first part,
Mm, mm,
so
mm,
the data, like here, like 80 GB is divided into like four servers, say like four replica
mm,
or four
mm,
sharding.
mm,
So
mm.
that 20 GB is unique, right? Like 20 GB is unique,
Unique.
other 20
Right.
are
Yeah.
different, right? So if that 20 GB is down,
Mm.
so like first 20 GB is down, like how do we get that particular 20 GB data?
See, if your range is falling that down replica set, it will give that won't give the data at all. It will come with the without the response basically. It look for the data. It always look for the available shards, not for the down. If you make it online, it will pick up that shard also and get the data out of it. If it is down, it is look for the data in the available charts. If data is there, it will give you the response. If not, it is not going to give. Then they'll complain with admins, we are not seeing the data. Then we will locate in the background. If anyway we will have the alerting. If this is down, you get the alert, like so and so node is down, we will try to work it on. Anyway, you never see that situations. Why? Because replica set, this is down, it will pick up the as a primary, it will start responding to the business. So you never see that one shard goes down. I never seen completely went down and we operated with a data gap. But yes, it can happen. If it happens, complete shard is down and it still operates with the available data. If it is trying to query the data which is there in this one, it does not give the response because it's not there.
Okay, so even
So
this 80 GB is yearly wise, say like I say on a monthly basis. So the first 2 months will come into the fourth one, and the next 2 months will come in the second or the third one. So it is
No, no,
also
no.
the
It's
partition
not
kind of thing.
month-wise data. It's not month-wise data. Every month
No,
data
like
is divided. Every day data is divided. It
so
is a
every day data, say like first
mm.
2 hours it is going in the fourth, next 2 hours is going in the third,
It's
like
not
that.
hours.
I mean, like,
It's not hours. It's not hours. Number of chunks, the difference of chunks. Number of see, a chunk is 64 MB. 64 MB split into multiple chunks because it is exceeding 64 MB. And number of chunks, differences are coming. Differences are coming. If greater than 80 chunks, it will try to keep eight chunks difference between the replica set. Example, in a single day, 100 chunks you loaded. Assume a case. 100 chunks if you load it, 40 chunks here, 30 roughly 30 31 chunks are here and here. Every data, every day data, every hour data, every minute data can be distributed if it is following this differences. It's not day kind of,
okay.
it depends on the number of chunks differences.
so if one of the replica set is down, so
Hmm,
that means this whole of whatever the data been sharded,
hmm.
it is not available for
Exactly.
anything.
Exactly. That you are correct. Absolutely, you are correct. So you have, like 20 GB, 20 GB, and 20 GB, 60 GB data, and this is down. 20 GB, when you read, it will only show the 40 GB. It does not read this one. Why? Because it is down.
Yeah,
But anyway, you get the alert. You start working on it as a DBA. You have your own alerting mechanism.
yeah.
That must be done. So Mongo does not go down because of one shard is down.
So, Ravi, if that database will sit on any one of the replica, right? So that replica goes down also, I can still able to access the data, right? When
Right,
it's
right.
settling down.
See, when it is migrated, database is created and collection is also added. When it is migrated, if it is you did not shard and it is sitting one replica set, if it is down, the complete database will be down. But if it is sharded, it is there in other shards also. That's correct.
Okay. Yeah.
So basically, in each replica set, it creates its own database and keeps the chunks of it. And
Exactly.
when it is so it is divided into three databases. and then when it is pulling it back, it gives it back as 1 or something like
Yes,
that.
as one. Yeah, yeah, as one. Why? Because this is config knows their database is sharded. No. Yes, and collection is sharded. Yes. Where the data of this collection? It goes to every like a sharded replica and give you controlled data if you are reading it basically. If you are giving condition data where it is there, it will go and fetch the data from the backend and give you the data.
Okay. So is there anything like does it have anything something like a jobs or something where SQL agent jobs where it does the maintenance of every periodically? These are all automated stuffs.
Fully automated. There are auto split or auto load balancer. There are two processes which will run every second. It is looking for the chunk reaching 64 MB. It will dividing auto split automatic processes. You don't need to build your own. It is a fully automated background operation. It does everything for you.
So it is already inbuilt coming from the
Inbuilt.
Mongo that.
Yes, it has to. Then only this technology can work very efficiently. We don't
Right.
handle it. If you want it, you can disable it, but by default it is enabled. We don't disable it. If you disable, distribution of data will be go in the bad shape.
Okay.
Bad shape means data will go into one shard only. It will pick up the data and it keeps the address of that data anyway. But you see the like what is the point of sharding to divide the data? So division is not happening. That's not good.
Right. Right.
Yes. See, when the chunk is migrated, it will show the same database name in all charts. When the one chunk is also migrated, same database in all charts.
Okay. So it creates the same name database on each replica, and then it knows like where to integrate.
Right, right. That's it. That's correct. So again, two things we have: range based, one shard it will write and migrate in the background based on the difference of chunks. Hash based is something it will, when it is writing itself, it will divide the data. No much of migrations will happen, but data will shuffle a lot. That will make the reader slows. But when it range based will make faster read. Why? Because data is continuous in each chunk. So wherever it is trying to read that chunk of data, it will read at a time all the chunk. So it will get the much IO performance. Why? Because you have all the data at one chunk and read out and give the response. It will be faster. You're finding the data in all the data what you're looking in one chunk. That is good, right? You don't need to go to and find the data in each node kind of. This is something you have to consider. One they are business looking at? Writes faster, reads slower. Writes slower, reads faster. What the business is requiring? They are writing too much data or reading too much data. Based on that, you have to define which sharding model you want to use, range based or hash based. So this is enough. Anybody have any question on the architecture? Let's move to the slides if you don't have it.
Coming
Anyone?
to this, Ravi, I
Yeah,
have a
Santosh.
quick question. How do we manage, like, I know like MongoDB is basically to, I mean, business requirement is to maintain the volume of the data coming, right? So how do they
Mm-hmm.
maintain like yearly basis? Say I have a lot of data coming on a monthly basis
Mm-hmm.
and I want to separate that. Like every month I want to just archive those data. Archive means I may need it for future use, but I like
Mm.
a table partition we have in RDMS, right? How do we do
Right.
that like here?
No archival here as long as you separate into one more Mongo. Like you write a condition on the router and send the segment of the data and clean up the data in the existing one. It's a manual process. There is no auto archival. That is the reason you operate all the data as long as it is needed. If not, you have to write a query and pick up the data into another Mongo here. Once these of the data is offloaded here are written completely, delete from there. It is your job anyway to take the unnecessary data into one more archival server and delete from the live servers. There is no such thing like it will take care of automatically. You have to take out the
Right.
data. Archive means you have to get the data, old data into other Mongo, and just like there's an archival only, and this is a live data where you are cleaning up all the old data on periodic manner to keep the data minimal. That is your job, developer job. They have to do it.
Yeah, we have to write some scripts and based upon
That's
the
it.
month or some date, we have
It's
to.
in any technology, you don't have auto archival as long as you give some condition and you give the pointer to somewhere it has to go the data and sit it right. Here you don't have auto archival. As the data is keep growing, you keep add more and more charts, it will distribute the data and operate. As long as you feel like you are loaded the data, you never need the data at all, just absolutely data just you might need on a situational basis, then archive it out of the cluster, like pull the data through router and load into one more Mongo, and once it is loaded into another other Mongo, just clean up from the live cluster, which can which can offload the live servers. Basically it all manual maintenance, there is no automation in that direction automatically, because system does not know, right, where it has to start the archival. You have to give the condition or run a job and instruct something. You have to do that, something come from us. Basically we know where the archival starts, till what point we need to get the data. It is a purely business basis. Everyone clear? Let's move the slides are so simple if you understood this. Right. So sharding. Once we enable the sharding on a collection, it's a collection level. On a collection, it will distribute the collection data automatically. You don't need to do anything. Just enable sharding and collection name. That's it. It will does everything. How shard keys affect the data? This is what we're going to talk about. How shard keys, range based, hash based, how it can affect the read, write, all that we're going to see. Setting up sharding, like starting the servers, and sharding data and production configuration. How we do what the recommendations we need to follow, kind of. Okay, sharding. The same thing what I said in orally, the same thing is there in the slides. Nothing more than that, nothing less than that. Sharding is the process of storing data records across the multiple machines and is Mongo approach to meet the demands of data growth. When you are distributing a lot of data, you can read a lot of data at any point of time, because multiple servers are serving your purpose and giving you the data. You don't have this technology in any of the RDBMS. In RDBMS, you have the high availability, but you can write only one copy at a time, not multiple. Okay, multiple secondaries you can keep it, that can be readable, not writable. Here all are writable. That's a big advantage. You don't have in any RDBMS technology. Oracle, if you take it, SQL, you take it, any technology you take it, in RDBMS you don't have where you can write the data into multiple servers. In Oracle you have rack concept where um, you can write the data in multiple servers, if you are aware of Oracle. So this is you can write, but ultimately one storage. These servers, or everywhere you can write the data. It is possible. It's a data guard, they will call it as, but all it will go to one share, one physical storage. There they operate it. So anyway, you are doing too much parallelly, you will see the lot of locking again. That cannot be so efficient anyway. But here Mongo is not like that. It has its own storage. It's everything is independent. So you are writing the data into multiple servers in more efficient way. That is allowed in the Mongo. In RDBMS we don't have that. So as the data size increases, single machine may not be sufficient to store the data nor provide an acceptable read and write throughput. If you are keeping everything in one machine, you are increasing more and more power. The thing is single point of failure. You don't have availability. Second thing is you will see the bad performance. Why? Because if data is growing more and more in a single machine, you cannot re-index, you cannot do the maintenance activities. That will become heavier to the system, and you cannot manage the system efficiently. That another drawback you have it. Sharding solves the problem with horizontal scaling. It is called horizontal scaling. Why? Because you're giving the power in terms of machine. You are giving to the Mongo. If these three servers are not scaling well, because data becoming overwhelming, you add one more shard. If again data is growing more and more, add one more shard. Automatic distribution happens. The performance will keep increasing in terms of machine addition. Horizontally you're adding it. See, it is horizontal. If it is RDBMS, within a single machine you keep more and more CPUs, more and more RAM. Vertically, it's a vertical scaling. This horizontal scaling. All NoSQL family servers are horizontal scaling, which means that multiple servers are serving your request in the background, not one. That is advantage of the NoSQL family, especially. Okay, that is said in the demo itself. I was pointing this. Okay, with sharding, we can add more machines to support data growth and the demands of read and write operations. So you keep more load, more servers, more performance, and it does not depend on you can go up to these many only. There is no limitation. You can add hundreds of shard if required. There is no limitation on that one. Each shard is an independent database, and collectively shards the make up a single database, single logical database. Physically, database is, if you see physically, I was saying, physically database is there. Each database in each shard is holding different data. They're not same. Here, one chunk of data is the other chunk of data, other chunk of data. But ultimately, consolidated data you can see from the router only. Physically, I'll do it practically. I'll chunk. We will see. We'll split the chunk manually. We'll migrate it. We will read it from here. You'll get some data. You'll read it from data. You'll get other data. We're going to see that practically. It's not only oral. Everything is practical. We have. Just we'll start in the tomorrow class. Tomorrow again Monday, right? Saturday, right? Anyway, sharding automatically balances the data across the shard. It is automated. Sharding provides additional write capacity by distributing the write or load over number of MongoDB instances. So which is going to do this? Can anyone tell? This is a point which applies to which range-based sharding or hash-based sharding. Sharding provides additional write capacity by distributing the write load over a number of MongoDB. Is it a range-based or hash-based? This point is pointing to.
Hash-based.
Hash-based, that's it. It's a hash-based. Good point. We should consider deploying sharded cluster if your data set approaches or exceeds the storage capacity of a single node in your system. Your data is really becoming big. You cannot keep the data, all the data, single disk also, or in a single server also. It won't scale well. The IO will throttle up, and CPUs sometimes, performance automatically come down because of data is giving more and more. One machine cannot scale with a large volume of data set. That's where sharding will come into advantage. The size of your system acting working set will soon exceed the capacity of the maximum amount of RAM of your system. Then you go for the sharding. Your system has a large amount of write activity. A single MongoDB instance cannot write fast enough to meet the demand, and all other approaches have reduced the contention. So see, what is MongoDB? It is made for the large data sets. If you don't deal with it, it's useless. So you definitely have to go to sharding when these conditions matches. When one machine is not serving the purpose, when some machine resources are not matching the data set what you have, and where you data is abnormally growing and one machine cannot capable of doing it, then shard it. What is shard? A given shard holds the document for which the shard key falls within the specific range of values. Shard keys like indexes. Shard keys like indexes can be either single field or multiple field. We can create a shard key based on the it is like an index. Shard is also an index on a field. Based on that, it will split the data. See, something if I'm saying here 1 to 100, 1 to 100 here, 200 to 300. That number I'm saying means that number, based on that number we are sharding. That field you have to impose the sharding on the field, on the index field, and which field you have index, there you impose the sharding. Based on that, it will automatically distribute the data. It need a field to do the distribution, one field, efficient field, where it can calculate exactly how much data it has to move, kind of. Anyway, in the further slide I'll tell you more in detail about it. Within a shard, MongoDB further partitions the documents into chunks. The default chunk of each size is actually 64 MB. This is what I was saying here, 64 MB, 64 MB. Okay. Each chunk represents a smaller range of values within the shard's range. When chunk grows beyond the chunk size, MongoDB split the chunk into smaller chunks, always based on the ranges in the shard key. See, if you see shard A and shard B, if the collection shards are going beyond, like the differences that comes into this difference, it will start moving the data automatically. It will split and distribute, split and distribute, split and distribute based on the number of shards, number of chunks it is building, number of shards you have. Again, based on that, it will do the distribution of the data. Next, see, within a sharded cluster, you enable the sharding on a per database. First, you enable the database, then collection. Enabling the sharding at database level does not do the sharding on all collections. That means that a collection can be enabled sharding. First, you have to enable a database level, then collection. That way it is. Within the sharded cluster, you enable the sharding on database per database if required. Some database you don't do it because they are smaller. After enabling sharding for a database, then we choose the collection to shard. This is a big word. First, enable the sharding at database level. That doesn't mean that enabling database level it is going to shard all collections. No, you have to do it what collection you wanted. It is a collection level technology. For each sharded collection, we will specify the shard key, which means a field on which will impose a shard key. There is a field. The field must be efficient field we can pick up for the sharding. If you keep on the names, then names can be repeated. It should be a unique numeric value all the time. A unique numeric value will be used, which will be used for the sharding. A shard key determines the distribution of the data collection documents among the cluster shards. Yes, shard key only will define which, which number is loaded into which chunk based on the range of data. Basically, if you are going with the hash based, anyway, it will write the data equally in all the shards. That is a different story. If range based, it is writing into one chunk, and one chunk is continuously it is writing. When 30 to 64 MB is reached, 64 MB, 200 KB, it will divide the chunk automatically into 32 MB, 32 MB. Then the 32 MB data has the continuous data, the chunk. The shard key field that exists in every document in a collection. The shard key must exist. It is a unique. It must be there. Without that shard key value in the document, it should not accept the document. It must be there. Such a thing you have to. We discussed the validation. You remember? This field must be there. Then only accept the document. That way, there should be a value in every document should be there, that value. Based on that value, we are doing the sharding. So that way you are mandatorily asking the system to get this field, then only accept the document. If it is getting it, and look for the sharding if it is going beyond the range. MongoDB distribute the document according to the range of the values in the shard key based on the range. Like if it is example 2000 sitting in one shard, 2000 to 300 sitting, 3000 sitting in one shard, because it is a next shard. So that way it will dividing the data based on the shard. If it is range based, if it is hash based, this concept won't come. This kind of discussions. Why? Because it is by default distributing the data, shuffling the data when it is distributing. Impact of shard key. This is very important, especially what you are going to do with the system. Reads or writes, which are more? Based on that, you decide what you wanted. Don't go blindly. What this is, see, if you wanted to get the fair idea, actually my laptop got rebooted. I did not start. If you want me to quickly say that, come on. Before the class, I was trying to start the class before 10 minutes itself, but it just went for the updates and then stuck. I don't know reason. What was the reason? Anyway, we discussed these guys. Do you guys remember db.serverstatus.op counters and insert update? I was doing the insert. I was telling you that number is increasing. You guys remember? Counters. No one remember? See, I was doing the insert and insert counter is growing up. I was reading it. Reading counter was growing up. Update counter was growing up. You remember? Anyone? No one
Yes, yes.
remember? So that will give you the analyzation, what you wanted, what people are doing, more reads, more writes, more updates. So based on that, you decide on this. You'll get a fair idea what to go with, the range based or hash based. But anyway, you will consult the business. This is what range based, this is what hash based, which you wanted to. If at all you are taking the ownership, you never be a owner of sharding. You configure the technology, give it to them. Whose responsibility to shard a collection is a developer responsibility. It's not at all DBA responsibility. But as a DBA or architect, or you become a senior, you are expected to advise the people if they are not doing things in efficient way. That is there. That is the reason you have to aware of all of this. Choosing the correct shard key can have a great impact on the performance, right? Of course, the capability and functioning of your database and cluster, very huge impact. If example, I'm trying to build a range-based sharding, but I'm writing a lot of data, reading less. In this case, you get the bad performance. Why? Because you're writing too much data, reading less data, and going with the range-based, absolutely not matching. You're going in the reverse order. You don't get the good performance. So that is what you choose, what is going to have a great impact in a bad way and good way. Depends on what you're choosing, correct one or wrong one. Based on that, you see the lot of impact on the performance side. Appropriate shard key choice. Again, shard key also makes more performance, like it can happen. See, if I'm imposing the shard key and the numeric value, it is easy for the system to distribute well. If I go with the text-based field, text can be repeated multiple times. If that happens, it won't distribute well. Distribution won't go well. So what field you're choosing for sharding also matters equally. What is hash based, range based is the technology to distribute the data, but again, on which basis it has to distribute the data, on which field it has to distribute the data, that must be a efficient field, like numeric values, not the text values. You have to supply to that. You don't understand this point yet. Why? Because what is sharding, on which basis we are sharding, you don't understand. How sharding is working, you understood, but there is a field, it work on field based. The field what you use for sharding, it should be a numeric value, it should not be text value. If you go with the text, the cluster does not do the efficient distribution of the data. That's another big drawback for us. So sharding
Like
hmm.
Ravi, I can define, like if I define like a year wise, so it will shading goes to like
No,
year
no, no, no,
wise. I
no,
can define that
not
shad
year
key.
wise. It's not a year wise, it's about the value which will distribute between the different chunks. How efficient it is distributing the data based on that value only. See,
Shad.
example, I'll tell
like,
you one example.
like
See,
integer based data, not character based data.
like numeric values, you have to keep it. Example, let me tell you. You keep example India as a sharding. Okay, India and the India field. India is repeated and repeated and repeated, and there is one more country is repeated and repeated. It does not go with the only, like India. Okay, it is repeated value where it has to cut off the chunk basically. So text is something, it will confuse the Mongo, like where it is started, where it is ended. It does not know. All are India. When it is you are trying to read the data from the shard field, everywhere India, where you wanted to filter it out, the filter does not work well. So a field should be unique and numeric so that the distribution of data goes evenly, and the read also can happen easily on that one. Two advantages we have. See, when you need a shard key, you need an index. Index is going to help you performance because we discussed that. And on the same field, we are imposing the shard. So you are getting the performance in terms of index. You are getting the efficient distribution of the data using the same index value. Two benefits we do get it. I'll pick up this tomorrow when I talk about practically. Then only you understand it. You don't keep this point out. Impact of shard key. Which field you are choosing for the shard? That makes very bigger point again. We will discuss tomorrow because I start things practically. Choosing ideal shard key. This is where I'm talking about. See, ideal shard keys, it is easily divisible. Divisible means, if you to go with the text is not divisible. A number is divisible. That's what I was talking about here. The field what you choose must be divisible and easily can be distributed based on the value range set. See here, ideal shard key is easily divisible, makes it easy for Mongo to distribute the content among the shards. If it is a number, it is easy. If it is text can be repeated. If it repeated text where it sees, that will where it does not do the efficient distribution. Will distribute the right operations among the cluster to prevent any single shard from becoming a bottleneck. This is hash based. Will make it possible for Mongoose to return the most queries operations directly from a single specific MongoD instance. See, one thing is two things that the slide is talking about. You're connecting to Mongo and getting the data from all the shards equally, because equal means all the shards is reading and giving you the data. At the same when I'm writing it, you are not flooding one Mongo. In case of hash based, all are getting written. Two directions it is talking about. Read, you're getting the good read because multiple servers are giving. When you're getting the good write, multiple servers are writing in the hash based. In both the points it is highlighting. We'll distribute the write operations. We'll distribute the read operations here to get the data from single MongoDB instance, which is a mongoose basically. Range based sharding. Okay, let me conclude few slides, guys. Give me 10 minutes. I'm going to finish this. Tomorrow we'll start the practical. Tomorrow means Monday. Where are we? Range base. MongoDB divides the data into ranges determined by the shard key values. Ranges means range. See, range anyway does not define where it has to cut off. The size will cut off. Basically, the size will cut off. Okay, see, it is exceeded 64 MB, but the range also matters when you are reading it, because range is 32 MB data is there. 32 MB data is in the continuous form. When you are reading that chunk of data, you read that chunk, you get the output. So no need to search for it. That's where the range based will give the benefit. MongoDB divides the data into ranges determined by the shard key values. MongoDB partitions this line into smaller non-overlapping ranges called chunks, where chunk is a range of values from some minimum to maximum. See, every chunk is 64 MB. 64 MB has a values. The values there in the chunk is a minimum, maximum. Minimum, maximum is held by the config server. It does not hold all the values what you have in the chunk. It will only hold the starting value of the chunk, ending value of the chunk, that will be there in the config server. In the sharding technique, document with a closed shard key are likely to be same in the chunk. Okay, this part you don't understand. I'll explain this tomorrow. What happens in the background? You have a chunk here, 1 to 100. Okay, 1 to 100. Now next chunk will start with 100 only, 100 to 200. Next chunk, if you look at, it will start with 200 to 300. This last number will repeat in the next chunk beginning. Last chunk value of the, like this is a chunk, first chunk, it started with 1, ended with 100. But the next chunk value will start with 100 only. It is telling that last chunk is, when you're reading this one, it is telling that last chunk is ended with 100. It's not that it is including the 100 here. This is what exactly, if this is very important point again, last value of the chunk will include in the next value, because when you're trying to read this chunk without this help, it is telling that last chunk value is ended with 100. It's starting with means, this is what it is saying, that in the sharding technique, documents with the closed shard key values are likely to be in the same chunk and reference on the same shard. Anyway, this part is not making much sense word, but physically I'm going to show that tomorrow. See, everything what we said today, we're going to see it practically. You get the more insight, which will add the more understanding to today's discussion when we start the practical. Range-based sharding supports more efficient read range queries. This is what I was saying. If range-based will give you the more read efficient, because the data is in the order. However, range-based partition can impact the write operations. The same thing I said. Writes will be slower, reads faster. What you wanted, you have to choose that. So writes will get impacted. Just a minute, guys, just a minute, someone is. Sorry, guys. So give me 10 minutes. It is Saturday, right? I'll just try to read out this three more slides anyway. Deploying sharding, this comes into practical. This also comes into practical. Production cluster. Okay, till this point, maybe 3 more slides. Just okay. We seen range-based sharding and hash-based. In this sharding technique, MongoDB computes hash of a field that field's value and then uses the hash to create the chunks. Actually, it's a different algorithm. Hash is an index basically. Hash is index basically. It is designed for making the values like in the equal order. I never used personally these indexes, and in our environment also we are going with the range based. We are not use the hash based anyway. Hash is something, what you need to get it in, only one thing you get it. Hash based, what it does the data distribution equally when it is writing. That is the only thing you keep in mind. In the hash-based sharding, when it is writing itself, data is distributed all across the shards, writing itself. In the range-based, it is writing into one shard and distributing in the background. But in the hash-based, writing itself is distributing it. That point you have to keep in mind. Other than that, don't worry about it. With a hash-based partitioning, two documents with a closed shard key are unlikely to be part of the same chunk. Here you no need basically. The chunk will hold the, if in a range-based sharding, I was saying this 1 to 100, 200 to 200. Here you don't need it. 201 to 201 to 200. Here it will start with 201 to 300. It won't repeat the value it is saying that. Anyway, I did not implement the hash base. We'll try to do it. We'll see. Hash-based sharding ensures more random distribution of a collection in the cluster at the expense of range queries. See, it is distributing the data and shuffling the data. And if you're trying to read a range query will be slower. At the expense of range query means at the expense of more power when you read it. You need more power because the data is shuffled out. It has to read the data across the shards, and finding the data is a tough part for the system, where the read operations will get slower. Expense of range queries means that basically. Benefits of shard key. Only one more slide, two more slides. That's it. We are going to finish. It is too late maybe for you. Just two more slides. Write scaling. See, benefits of shard keys. Write scale or read scale. What defines? If see, I'll ask this question. Is it range-based read scale or write scale? Scale means what give performance.
Read scale.
Read
Right scale.
Right.
Right.
Hash based.
Yes,
Right.
Right. Okay.
Right scale. That words you need to know. Right scale is given by the what sharding?
Hash
Right
based.
scale. Hash based. Good. So write scaling. Some possible shard keys allow you or application to take the advantage of increased write capacity that the cluster can provide, while others do not. Others means the range based does not give you, but hash based will give you. MongoDB makes it possible to shard a collection on a hashed index. This greatly improve the write scaling. Of course, we discussed that. Query scaling, which can do read scale. Query means read the shard range based. Mongo receives the queries from the application and use the metadata from the config server to route the queries to the MongoDB instances with appropriate data. The shard key you select can have the profound effect on the query performance. Shard key means range based shard key, hash based shard key. If it is a range based shard key, you get the good performance for the read. If it is a hash based shard key, it will get the lower performance with the read. So it is indirectly saying that what sharding mechanism you use it, that will have a great impact on the read capacity. Query isolation. The fastest queries in the sharded environment are those that Mongoose will route the single config server using the shard key and cluster metadata from the config server. What it's saying is, if I'm writing some data or reading some data, you are giving the request to multiple servers, and multiple servers are independently working and giving you the data to Mongoose. Mongoose is giving the data to the application. Independent isolation means every shard has isolated data, means different data, not the same data. Whatever data is here, you are clubbing all of the data together and getting data through router, through the config, with the help of the config server, and giving to the application. It's not one thing. Isolated data in each shard and reading the data and giving it to the application basically. That's what it is pointing to anyway. Production cluster. If you see guys how it works, these are all applications. They'll hit the router. Router will contact the config server to get where data is sitting. It'll route the traffic, the request to the shards based on the config server data. Then it'll read the data. It'll give the router. Router will give you the application. When the data is read out, it does not contact the config anymore. Why? Because it got the data what it want. It is giving to the router. The data set is giving to the router. Router giving to the application. It was only contacting as a mediator. Why? Because the router need to know where the data is. The config server knows. Config server is telling that to the router, okay, you are requesting this data is sitting in these and charts, go and get it. Once it is directly getting and giving to the application. This is the architecture. Right, we'll have a config servers. There are 3 config servers. Each server must have a separate machine. It is talking about the deployment methodology. See, this is so important. Config server. Without config, we cannot achieve the data reads or writes. Why? Because it has to go through the config only. If it is not config, you cannot write. As simple as it is. Why? Because config should maintain the metadata. Without metadata, you cannot operate. So config servers must be configured with the replica set. One is down, other should be there all the time. If config all data nodes for the config, all data nodes, we don't go with the arbiter with the config. Why? Because it will keep very minimal data. It does not keep GBs and TBs of data. It's just minimal data. It is a reference of data, minimal data. That's why all keep it as data nodes so that you get the more redundancy. Even this server is down, this will operate. Okay, and this is also down, this will operate. At least we can force it to become primary and start working with the shard for time being. So you need more data sets. You don't keep arbiter in the config server. Only for data, 2 data nodes, 1 arbiter, 2 data nodes, 1 arbiter, 2 data nodes, 1 arbiter, like that in the sharding model. In the replica set, always we keep in only 2 data sets, 2 data nodes, 1 arbiter all the time. This is only voting node, not the data node. You're giving more power to 2 system, not to other one, because just arbiter. This is everywhere will people will be followed. You don't need 3 machines with data. If your client is too rich, you wanted that like more secure enough, then you go for it. It is up to the infrastructure cost approved by the business. You cannot take the decision. So if you have multiple sharded cluster, you will need to have a group of config servers. Group of config servers means the more and more config, the more and more better availability. Shard 2 or more replica sets. Each replica set will become a shard. So each replica set called as a shard here. Sharded replica. We'll call that way. This last slide, guys. Query routers, Mongoose. One or more Mongoose instances. Mongoose instances are the routers for the cluster. Typically, deployments have one Mongoose instance on each application server. Example, you have a cluster and you have one application, 2 application, 3 different application. Each application will configure one router. Router does not hold anything. It's just a Mongoose instance. It does not hold any data. It does not even need a data directory. You just need a log directory. Data directory is not there for Mongoose because it does not keep any data at all. You don't need a data directory. Just a log directory is enough for this. Data directory, I don't think we'll see tomorrow, Monday. Okay, this is about everything, guys. Deployment and everything will come with the practical. We're going to see all of this. I'll give you fair notes where I use that always for configuration. I'll talk about each step what I do follow in my environment. I mean, the sequence of steps I do follow for the configuration. It is little lengthy configuration, but simple. I'll make it very simple. No need to worry. Very, very simple. Anybody can configure sharding. It is, if you go through Google and videos, they don't talk all of this for sure. I mean, you try to find it out in the Google, YouTube also. You don't get the sequence of configuration properly. Anyway, I'll give that. Any questions before I wind up? Anything you want to ask something about this diagram or anything you have in your mind, just ask. Quite then stopping it.